Hello everyone, myself Mustafizur. I am a student of Don Bosco School of Technology, Azara, Guwahati. I am going to present channel and modulation. There are introduction. There are several short channel effects in MOSFET scaling. Channel and modulation is a shortening of the length of the inverted channel region, which increases the drain bias for large drain biases. When BDS is increases after pinch of voltage BP is equal to PGS minus PTH, then the depletion layer at the drain increases, which leads to short channel length and increases drain current ID. This phenomenon is called channel length modulation. This is the cross section of an NMOS. This is the drain, this is the gate, and this is the source. When BDS increases, then BDS is greater than pinch of voltage, then here you can see the depletion layer at drain is increases, and which is leads to increases the drain current. Here graphically you can see this is the pinch of voltage. Graphically the effect of the channel and modulation, you can see this is the pinch of voltage at here the ID is almost constant. Here the ID, and after the BGS is increases, the channel is depletion layer at channel is like this, and if the BGS BD is increases, then the ID is the depletion layer will be like this. The drain current equation due to channel and modulation. Here lambda delta L is directly proportional to BDS minus BD saturation, and ID is proportional to 1 by L minus delta L, which is equal to 1 by L whole into 1 plus delta L by L. And finally we will get the ID current is equal to 1 by 2 half of mu x cox mu w by L BGS minus BTS whole square 1 minus lambda into BGS minus BD saturation. Lambda and L. The effect of channel length modulation is less or long channel MOSFET than the short channel MOSFET. Here graphically you can see if the length is more, then the channel length modulation effect is less. If the length is less, the channel length modulation effect is more. The output resistance. The output resistance in channel length modulation is equal to R0 is equal to delta L derivation of BDS with respect to ID is equal to, which is equal to 1 by lambda into ID. Here ID is maximum. The transconductance Gm and G suffix M. The G suffix M measures how much drain current change when gate voltage changes. Here we can measure the transconductance in channel and modulation, which is equal to derivation of ID with respect to BGS, which is the result is lambda L lambda into ID. Finally, conclusion. After the above study, we understand that the channel and modulation is a very useful phenomenon to design a circuit. The result of channel and modulation is increases in current with drain bias and the reduction of the output resistance. Channel and modulation occurs in all field effect transistors, not just MOSFET. Thank you everyone.